Hi everyone, welcome back. Val here again. And in today's video, I wanted to talk about AI. Specifically, I wanted an AI that actually reads research papers and tells me where it got things. So I built a tiny research assistant. It searches arXiv, pronounced archive, indexes papers, and answers questions with citations. In this video, I'll demo it, show the architecture, and give you everything to run it yourself, local mode included, so it costs $0. Are you ready? Let's go. As a quick overview, here is what we will do today. We're building a small rag app, said like the cloth rag, and as you can see here, we have a file named rag.py. Our front end is built with Streamlit. Our backend is built with FastAPI. We also have Chroma. Chroma stores vectors, and we can run the app either with OpenAI or fully local using a sentence transformers model. You'll also get a make file, one-click scripts to start and stop the app, as well as a UI that shows answers with sources. Before we jump into the architecture, I would like to show you a live demo first of the app. Let's go ahead and pivot back to our browser. Okay, back at our browser, we'll now navigate to 127.0.0.1 port 8510. And here is our app. On the left-hand side, you can see the backend URL is pointing to 127.0.0.1 port 8010. We'll first go over ingest papers. And then we'll type something like large language models evaluation, set max results to 10, and then click ingest. Under the hood, that hits the /ingest endpoint, pulls titles and abstracts from arXiv, embeds them, and then saves them to Chroma. That's my local vector store. We'll now ask our assistant a question. You can ask something like, what are current best practices for RAG evaluation, or any other question you may have, and then we'll go ahead and click ask. The model retrieves the top K relevant abstracts and builds an answer with citations. I can click one or two and open the exact paper. So if I quote something, I can prove where it came from. As a quick heads up, I'm running local mode right now, so no API key, no cost. You'll see the first run download a small embedding model, and then after that, it's instant. So that's the user experience, ingest topic, ask, and cite. Now, let me show you how it works. The architecture is a very standard retrieval augmented generation flow. First, Streamlit, our front end, sends a /ingest with our archive query. Next, FastAPI, our backend, fetches matching papers, builds documents from title and abstract, and creates embeddings, either OpenAI or all mini-LM L6 v2 locally. Those vectors and metadata go into Chroma on disk, so the index persists. And then, when you click ask, we embed your question, do a nearest neighbor search in Chroma, take the top K hits, and construct a prompt that includes short source snippets. Lastly, in OpenAI mode, we ask an LLM to answer and cite. In local mode, we do a simple extractive summary from the retrieved abstracts. The key is provenance. Every claim maps to a source. And today, we index abstracts for speed. Later, we can pull full PDFs chunk them, and re-rank. Now we'll run the app locally. As you will soon see, everything runs with 2 commands, and all my bash scripts are packaged into executable files located in this scripts folder here, as you see. And the first thing I'll do is set local mode. So I'll go ahead and input that command. Okay, local mode has been set. Next, we will start the backend on port 8010 and the UI on 8510. Let's go ahead and run that command now. And as we can see here, our server was already started, so we are good to go. We will now take a look at our code. The first file we will look at is the archive_client.py file. Let's go ahead and click into it. And essentially what this file does, it's a tiny client that uses the archive Python package. We search, pick out ID, title, authors, summary, a link, as well as the publish date. This is the only external fetch in the whole app. Next, we will look at the ingest.py file located inside the backend directory as well. Let's go ahead and click into it. And ingest builds 1 document per paper, title plus abstract. Chroma requires scalar metadata, so we flatten the authors list into authors_.string. We embed the docs and upsert with the archive ID, which also prevents duplicates if we re-ingest. Next, let's take a look at the rag.py file, which is also located in the backend directory. And as we scroll down the code here, we take a look at this function. The get_embedder switches between OpenAI and local. Embed_texts runs the appropriate path. Build_prompt assembles a neat citable context block. In OpenAI mode, we send a low temperature request. Otherwise, we fall back to an extractive snippet built from the retrieved abstracts. Next, we will take a look at the main.py file also located in the backend directory. And in this file, we can see that it has 2 routes, ingest here, as well as the ask route here. Ask embeds your question, queries Chroma, rebuilds the authors list from author string, and returns answers plus sources. We also expose the /healths endpoint for sanity checks, and use permissive cores for the local UI. Lastly, we will talk about the app.py file located on the front end. And as we look at the code here, we use Streamlit to build our front end UI. We also have a sidebar to set the backend URL, and ingest papers expander with query and max results, as well as the ask section right here. The answer renders with clickable sources, so you can open the paper quickly. So, why not just use ChatGPT? And that's a very good question. And I'll say this about it. ChatGPT is fantastic for quick ideas and explanations, but it's ad hoc. No fixed corpus, no persistent index, and repeating the same exact Q&A later can vary with context. This assistant is your research tool. You define the corpus, you get consistent citations, and you can reproduce results on a fixed dataset. It's easy to automate, say weekly ingest on a topic or generated brief, and you choose privacy, local or cloud. Okay, that wraps up today's video. The repo is linked below. Clone it, run local mode to keep it free, and tell me which features you want next. Maybe PDF parsing, re-ranking, or even an eval dashboard. If this helped, please leave a like and a subscribe, and I'll see you in the next one. Cheers.